In this video, we're going to look at how to balance chemical equations. So chemical equations, of course, must obey the law of conservation of matter. And this tells us that in a chemical reaction, matter, such as atoms, can neither be created nor destroyed. So the number and type of atoms that we're going into a reaction with must be the same number and type of atoms that we come out of a reaction with. Stated differently, the reactant and product side of a chemical equations must have the same types of atoms. And the number of these atoms must also be the same. If a chemical equation obeys the law of conservation of matter, then we say it is balanced. So how do we balance a chemical equation? Well, first of all, we cannot add subscripts, which are the small numbers. We can't add, change, or remove those when we're balancing a chemical equation. Subscripts, we only add or change subscripts when we're writing a chemical formula, not when we're balancing an equation. So for example, take a look at this chemical equation. H2 hydrogen plus O2 oxygen gas yields water, H2O. You can see this is not balanced because we have 2 oxygen atoms on our reactant side and only 1 oxygen atom on the product side. If we wanted to balance this, we could not balance it by adding a subscript 2 behind the oxygen. When we add that, again, we change the chemical formula. So now, instead of hydrogen plus oxygen reacting to produce water, we're saying that hydrogen plus oxygen react to form a whole different molecule, hydrogen peroxide. And we can't do that when we're balancing an equation. We can't change the meaning of the compound or the types of compounds that we have as our reactants and products. So that's very important to appreciate. Secondly, we can add or change coefficients, which of course are the big numbers in a chemical equation. However, when we add or change coefficients, we can only put them in front of the chemical formula, never in the middle of a chemical formula. So if we look at our reaction again, hydrogen plus oxygen yields water, we need 2 oxygen atoms in order to balance that. We cannot put a coefficient of 2 right in the middle of a chemical formula because again, this is an incorrect chemical formula, so we would not want to do that. When we do have a balanced chemical equation, the balanced chemical equation should be the lowest whole number ratio of coefficients. So for example, here we have 4 hydrogens plus 2 oxygens yields 4 waters. We have the same number and type of atoms, but again, we could simplify those coefficients. We could reduce that equation to 2 hydrogens plus 1 oxygen yields 2 waters. So the correct balanced chemical equation would be the equation with the lowest whole number ratio of coefficients. So let's take a look at how to balance an equation. Here we have an equation that we need to balance. So the first thing is to determine the number and type of atoms on the reactant side and the product side. So I'd like to make a little table. I can see on my reactant side I have carbon atoms, hydrogen atoms, and oxygen atoms. On my product side I also have carbon, oxygen, and hydrogen atoms. Now I need to figure out how many of each atom I have. So I count them up, and you can see that here we have 1 carbon, we have 4 hydrogens, and 2 oxygens. So 1, 4, and 2, that's the number of each atom. On the product side, I have 1 carbon, I have 2 oxygens here, and 1 here. So I have a total of 3 oxygens. They don't all have to be in the same compound. We're just counting up the total oxygen atoms on the product side. So we have 3, and we have 2 hydrogens. Now let's compare those. You can see that our carbon atoms, we have the same number of carbon atoms, but hydrogen and oxygen atoms are different. So therefore, this is not a balanced equation. So to balance it, we have to add coefficients in front of each compound or element where appropriate. And so I'm going to start with hydrogen. I can see that I have 4 hydrogens over on the reactant side and only 2 on the product side. So I'm going to add a 2 coefficient in front of the water. Now that's going to change the number of hydrogen atoms to 4 and the number of oxygen atoms to 2 plus these two, a total of 4. So I have to recalculate the number of atoms after I add the coefficient, and that gives me 1 carbon, 4 hydrogens, and 4 oxygens. Now, my hydrogens and carbons are good, but my oxygens are not the same, so they're not balanced. So I have to continue this process of adding coefficients until all the atoms on the product and reactant side are the same in type and number. So I'm going to add a coefficient of 2 in front of my oxygen, and that's going to change my oxygens on the reactant side to 4. Now we have a complete balanced equation. So take a look at this equation and see if you can balance it going through those steps. Pause the video and give it a shot. Okay. So first, I'm going to determine the type of atoms. I have nitrogens and hydrogens on the reactant and nitrogens and hydrogens on the product. Now I'm going to count them up. I have 2 nitrogens and 2 hydrogens on the reactant side, 1 nitrogen and 3 hydrogens on the product side. So comparing these numbers, I can see it's not balanced. So I'm going to add a coefficient of 2 in front of the nitrogen because I need to get 2 nitrogens on the product side. Now I need to recalculate the numbers. On the product side, that's going to give me 2 nitrogens, and 2 times 3 is 6 hydrogens. So my nitrogens are good, but now my hydrogens are not balanced. So I'm going to add a coefficient in front of the hydrogen, a coefficient of 3, and that's going to give me 6 hydrogens, and now this would be a complete balanced equation. So let's practice a few more. Pause the video and see if you can balance this equation. Okay, so on the reactant side, I have 1 iron, 2 oxygens, and I'm starting out with 2 irons and 3 oxygens on the product side. Of course, it's not balanced, so I'm going to add a coefficient of 4 in front of the iron, 3 in front of the oxygen, and 2 in front of the iron oxide. So again, I'm just skipping some of the steps to show you the final answer here. And that will give me 4 irons, 6 oxygens on the reactant side, 4 irons, and 6 oxygens on the product side. So let's try a couple more. See if you can balance this equation. Pause the video and then take a look at the answer. Okay. So I'm starting out with 2 carbons, 6 hydrogens, and 2 oxygens, 1 carbon, 2 hydrogens, and 3 oxygens on the product side. So my final answer is going to be 2 in front of my C2H6, 7 to give me 14 oxygens, a 4 in front of my carbon dioxide, and a 6 in front of my water. So my final numbers, I have 4 carbons on each side, 12 hydrogens, and 14 oxygen atoms on both sides of my reaction. So this would be my final balanced equation. Let's try one last one. Take a look at this equation, and for this one, you see that there are polyatomic ions. For example, nitrate, chromate, and over here we have chromate and nitrate. So when you're balancing equations that have polyatomic ions that don't change, this nitrate is the same, it hasn't broken apart in our chemical reaction, and the chromate is the same on the product and reactant side. It hasn't broken apart. We can treat those polyatomic ions as one unit, and so it may help you balance it a little faster. So pause the video, give it a try, and then take a look at the answer. Okay, so I'm starting out with 1 silver, 1 nitrate, counting that as 1 unit. I have 2 sodiums and 1 chromate. On the product side, I'm starting out with 2 silvers, 1 nitrate, 1 sodium, and 1 chromate. So it's not balanced, so my final answer would be 2 silver nitrates plus 1 sodium chromate will react to form 1 silver chromate and 2 sodium nitrates. And you can see once I've added the coefficients, all of my atoms are balanced. So practice balancing these and appreciate what these numbers, the coefficients and subscripts, tell you. You want to be very proficient at that.